Moving on to 4.3, orbital overlap and hybridization. So the minimum mark for this subtopic is 7 marks. Okay. So if remember that when I said that if you got your Lewis structure or molecular geometry wrong, then you've got the whole question wrong. So you need to be careful when you are doing this question of orbital overlap and hybridization. So first, so for 4.3, I want you to write down the summary in anywhere in your note. So for 4.3, there are two things that you have to know. The first one is to know the type of hybridization. The second thing is to know about how to draw your orbital overlap. And these points were already given by me in for first type of hybridization. Okay, you have to count how many sigma bonds. Okay, delete this pi bond, sigma bonds, and lone pair in the molecular geometry to state your type of hybridization. Okay, so highlight of this formula. So to determine the type of hybridization, you have to calculate the total number of sigma bonds and the lone pairs. What I mean by lone pair is that you have to calculate the pair and not the electron one by one. So for central atom, the type of hybridization for central atom, it is compulsory to determine the type of hybridization. Okay, again I repeat, for central atom, you must find out the type of hybridization. For terminal atom, only find it if your terminal atom bonded via double bond or triple bond. Okay, so if your terminal atom bonded via single bond, then you just don't do anything. Right? So let's try this molecular geometry in page of 48. Okay, so you've got CH4, CO2, and C2H4. Okay, make a star on C2H4 structure. Okay, this is a past year question. You are asked to draw C2H4, and many students got it wrong. Okay, so this is the structure of C2H4 with a double bond of C and C. So put a star on it. I want you to remember this structure. Okay, the first structure is CH4. Or before that, forgot to tell you one thing. So make some note. For single bond, you've got 1 sigma. For double bond, you've got 1 sigma and 1 pi. And for triple bond, you've got 1 sigma and 2 pi. So in short, for all bonds, you've only got a maximum of 1 sigma only. Well, let's say that if I've got like 6 bond, okay, for example, 1, 2, 3, 4, 5, 6, 7, okay, 7 bond, then the first bond consists of sigma and the rest of the bond would be pi. Okay, just for example, but you know that the bond that you're going to draw is only triple bond. Okay, so look at CH4. So this is the molecular geometry. Okay, I want you to know how to write the molecular geometry right now. So we're going to determine everything from molecular geometry, not the Lewis structure. For CH4, we got four single bonds. So look back again. So single bonds. So we've got one single bond consists of 1 sigma. So 4 single bond consists of 4 sigma. Okay, for carbon, remember that it is compulsory to determine type of hybridization for central. So look back at this formula. So you have to find out just how many sigma bonds and lone pairs. So for carbon, we've got 4 sigma and 0 lone pair because carbon does not has any lone pair around it. So 0 lone pairs. Okay, so remember back in chapter 2 when we learned that S would has 1 orbital, P would have 3 orbitals, and D would have 1, 2, 3, 4, 5 orbitals. Okay, so 4 plus 0 would be 4 electron. So how are you going to fill in this 4 electron into sp_d orbital? So fill 1, 2, 3, 4. So you are filling it, the electron in one s orbital and 3 p orbital. So you've got s1p3. So you don't have to write the 1. So it would be sp3 hybrid orbitals. Okay, write it down somewhere. sp3 hybrid orbitals. Okay. Write it down below it because I don't have any space left. Okay, so that's how you determine the type of hybridization. Okay, so for terminal atom, check. It is bonded via hydrogen bonded via single bond. Okay, so if it's bonded via single bond, then you don't have to do anything on it. You don't have to determine the type of hybridization. Okay, so it's simple. So let's try on CO2. So this is the molecular geometry of CO2. Let me delete this off. If for CO2, we've got 2 double bond. So for double bonds, we have 1 sigma and 1 pi. So for carbon, so the central atom is carbon. So you have to determine how many sigma and lone pair in this area. Okay. So for carbon, we've got 2 sigma and 0 lone pair because there is no lone pairs in carbon. So 0 lone pair. So that would be 2 plus O would be 2 electron. So how you're gonna fill in 2 electron in this SPD? So 2 electron means you are filling in 1 S and 1 P. So 1, 2. So you're filling in 1 S and 1 P orbital. Again, you don't have to write this 1. We already know that the power of 1 is 1. So S, P, hybrid orbital. Okay. So check for terminal atom. Is it bonded via double or triple bond? Yes, it is. So oxygen bonded via double bond. So by default, you have to determine the type of hybridization. Okay. So oxygen 1 is the same as oxygen 2, right? So we just need to determine only one to determine type of hybridization for just one oxygen. So we're going to do oxygen 1, which is the same as oxygen 2. So for oxygen 1, highlight of this area. So we've got 1 pi bond, 1 sigma bond, this one, and 1, 2, 2 lone pairs. So 1 plus 2 would be 3 electron. So 3 electron, we're gonna fill it in here. So 1, 2, 3. So we've used 1 s orbital and 2 p orbitals. So the type of hybridization would be sp2 hybrid orbital. The last structure is C2H4. Okay, so I've already made I've already split off the structure into two because both carbon 1 and carbon 2 are the central atoms. So again, so first of all, find the find the type of hybridization for the central atom, which is carbon. So carbon 1 is just the same as carbon 2. Okay. So split it off and determine your type of hybridization. So for carbon 1, you've got two single and one double bond. So it consists of 1, 2 sigma for two single bonds and 1 sigma and 1 pi for the double bond. So for carbon 1, we've got 3 sigma bonds and 0 lone pairs. Okay, so fill it in. So 3 plus O would be 3 electron. So 1, 2, 3. So that would be S1P2. So sp2 type of hybridization. So check your terminal atom. It is bonded via single bond, same as CH4. So you don't have to determine the type of hybridization. The second thing in 4.3 is to draw your orbital overlap. So for this, I want you to look at your point number 3. To draw your orbital overlap for central atom, you must state, okay, so it is compulsory to state all the ground state, excited state, and the hybrid state. So for terminal atom, again, state all your ground, excited, and hybrid state if the terminal atoms bonded via double or triple bond. And I need you to add on the last point. So if terminal atom bonded via single bond, then I just need to know the last orbital, the shape of the last orbital. So there would be either S or P orbital from electronic configuration. So remember back to determine type of hybridization. Okay, if it is bonded via double bond or triple bond, then we have to determine the type of hybridization. So if we have determined the type of hybridization, then we have to determine the ground, excited, and hybrid state when we're going to draw the orbital overlap. So turn on to page 49. I want you to copy down all of these in the notes in GC. Then you just have to remember that linear. So if your type of hybrid is SP, then it would have linear shape. So this is the shape of it, which is straight line. So if SP2, that would be trigonal planar, because trigonal planar you draw it like this, right? Okay, so if you want to draw the orbital overlap, so we're going to draw a loop. Okay. So for sp3 would has tetrahedral molecular geometry. So remember that the tetrahedral has a shape like this. So for sp3d, it is trigonal bipyramidal with 5 terminals atoms and 5 lobes. So for sp3d2, it would has a shape of octahedral. So all of this is just example how we are going for ground state to excited state and lastly to the hybrid state. So remember, what does it mean by hybridization? It is a mixing of two or more atomic orbitals to form a new set of hybrid orbitals. So before this, we only learned about S, P and D orbitals. So now we're going to combine them all together to become sp, sp2, sp3. Okay, so for sp3, for example, you are combining 1 electron from s orbital and 3 electron from p orbital to form this orbital called sp3 hybrid orbital. So for trigonal bipyramidal, you are combining one s, 3p, and one d orbital, and the rest will follow on. Okay, so you don't have to remember this ground, excited, and hybrid state. This is just a basic example.